Okay, now they want us to go the other way. They want us to find the polynomial of the smallest degree. I'll show you what that means in a minute. With integral coefficients, that means no fractions, that has these zeros. So now these are zeros. So what this means is whatever this shape is, since there's three of them, it'll look like a cubic. It means it's going to cross at -1, it's going to cross at -1/3, and at +3/4. It's going to go like this. They want us to find the function that makes this graph. Okay, these are the zeros. That must mean that this one came from x plus 1/3 as a factor. See, if this is the 0, that's where it came from. And this one came from x plus 1. And this one came from x minus 3/4. Okay, but the problem is that has fractions, and they don't want fractions in it. They want integers. Okay, well, if I multiply this by 3, that makes that 3x plus 1. See, that still has an answer of -3rd because we would have gone 3x plus 1 equals 0. We would have subtracted 1 and then divided off the 3. So it still gives us this 0, but now doesn't have any fractions in it. This one already didn't have any fractions. And then this one I'll multiply both pieces times 4. That'll make it 4x minus 3. Okay, so there are the factors without fractions. And now we got to turn that into the polynomial function. Well, it just means multiply it all together. So I'm going to take these two, doesn't matter what order, I'm going to take these two and multiply them together. Okay, 3x times x is 3x squared. 3x times 1, 1 times x, and 1 times 1. So that first piece is 3x squared plus 4x plus 1. Take that times this one. Okay, so I got 4x times 3x squared, that's 12x to the third. 4x times 4x is 16x squared, and 4x times 1 is 4x. -3 times -3 times 3x squared is -9x squared. I'm just putting those together because I'm going to combine them in a minute. -3 times 4x is -12x, and -3 times 1 is -3. So it's a grand total of 12x to the third plus 7x squared minus 8x minus 3. That equation is that graph with these zeros. Okay, let's see. I'm going to prove that. So I'm going to take my calculator. I'm going to type it in. It's 12x to the third plus 7x squared minus 8x minus 3. Okay, I'm going to graph that. Okay, look, it's almost exactly like what I thought it was going to look like. It's that shape. It looks like it's crossing at -1, -1/3, and maybe 3/4. There's a couple ways to confirm that. I hit quit. I could go to variables and stick those in and see if it hits equals 0. Variables, y variables, function y1, since I put it in y. So y1 is the equation. And now if I put in a -1/3. So if the equation is correct, -1/3 should make it 0. Okay, it does. If the equation is correct, then -1 should make it 0, which it does. And if the equation is correct, 3/4 should make it 0, and it does. That's one way to confirm that these are zeros of the equation I just put in, that we figured out. Another way is to look at the graph. I can ask for the zeros there. Second, calculate 0. Go to the left. So I'm going to move, I could type in some number over here, but I'm just going to move the little bug to the left of that one. So that's obviously, it's way down, but it's also to the left. And then it wants it to the right. So that's just barely, it's above, but it's also barely to the right. So when I hit enter, it should find that 0. And look, it's at -1. It found this one. So that formula, the graph has that as a 0. If I do second calculate a 0 again and try to find this one, okay, I'll go just barely to the left, and I'll come down, and it'll be barely to the right, but it'll search between there, and it should find that negative 1/3. Sure enough, negative 1/3, that negative 1/3 is one of the zeros of this formula of this picture. It's that one. And then second calculate a 0. I'll search for this one now. So there the bug is to the left. Now I'll bring the bug to the right. There it is to the right. And that should give me the 3/4, which it is doing. Confirming that that one is also a 0 of this picture off of our calculator. So we were we took these zeros, turned them into factors, made those factors non-fraction, multiplied it together, and there's the polynomial that has those 3 zeros. Okay, let's do that again. This multiple of 2, that just means x plus 3 is happening twice. So if it's got a 0 of negative 3, it has 2 factors of plus 3, and then an x minus 1/2. Okay, so I'm going to replace this one with 2x minus 1. I multiplied it by 2. Okay, multiply them together. So I'll take these first two and multiply them together. X times x is x squared. There's a 3x. There's another 3x. And 3 times 3 is 9. So those multiply together to x squared plus 6x plus 9. Take that times 2x minus 1. Okay, 2x times x squared is 2x to the third. 2x times 6x is 12x squared. 2x times 9 is 18x. Negative 1 is negative 1x squared. Negative 1 times that is negative 6x, and negative 1 times 9 is negative 9. So the whole thing is 2x to the third plus 11x squared plus 12x minus 9. That equation makes those zeros, makes the graph that has 2 zeros at negative 3 and another one at 1/2. Okay, 12. I'm not sure I'll do all of these. X minus 4, x plus 1, and x plus 3 are the factors. Okay, those can just get multiplied together. Nothing. Okay, there's nothing going on with this one too crazy, so I think I'll just skip that one for now. Let's go to 13. If that's a 0 and that's a 0, this is also a 0. Negative square root of 3. They always come in conjugate pairs. So this became x plus 1. This came from x minus the square root of 3. And this came from x plus the square root of 3. Okay, I'm going to multiply these two together first this time, because they're perfect squares. X times x is x squared. There's square root of 3, and there's negative square root of 3x. So that adds up to 0. And then negative square root of 3 times positive square root of 3 is minus 3. And now this one. X times x to the second is x to the third. There's a minus 3x. 1 times x squared is a x squared. And 1 times negative 3 is negative 3. So now if I just put all that in order, we got x to the third plus x squared minus 3x minus 3. No fractions. So number 14 will be very similar. I'm going to go on to 15. So if this is one of them, another conjugate pair would be 3 minus the square root of 3. Okay, now I've got to be careful here. So the factors will be x minus 4. Then it's going to be x minus this entire, see, this is a number, so it's going to be x minus the number 3 plus square root of 3. I'm writing it like that because that negative is going to go across both of them. And then also x minus this one, 3 minus the square root of 3. that negative is going to get into both of them. That's a tricky thing that people miss. It's easy to miss negatives here. So it was really x minus 4, and then x minus 3 minus the square root of 3, and then x minus 3 plus the square root of 3. Of course, I'm going to take these two and multiply them together first, and I'm hoping the square root of 3's go away, which I think they will. X times x is x squared. Here's a minus 3x. And here is a x square roots of 3. Okay, negative 3 times this one is a negative 3x. Negative 3 times 3, I guess I could have just put it here, negative 3x. Negative 3 times negative 3 will be plus 9. And negative 3 times square root of 3 will be a negative 3 square roots of 3. Now I got this last one. Negative 3 square roots of 3 times x is a negative x squared of 3. Okay, that's good. Those are going to go away. Here, a negative square root of 3 times a negative 3 will be a positive 3 square roots of 3. That's good. Those will go away. And negative square root of 3 plus another square root of 3 will be minus 3. So out of all of that, I've got an x squared, this one. I've got a negative 3x and a negative 3x for minus 6x. And then 9 minus 3 is positive 6. That formula has these three answers. Oh, I was going to say it can't have 3. That's only got 2 answers. I forgot to multiply it by x minus 4. Okay, so that's not the answer yet. X, so there's an x to the third. X times this one is minus 6x squared. X times that one is a 6x. Negative 4 times that is negative 4x squared. Negative 4 times that one is 24x. And negative 4 times 6 is negative 24. So this one has a grand total of x to the third. That's that one. Negative 6 and negative 4 is negative 10x squareds. Positive 6 and 24 is positive 30x minus 24. There we go. That's the cubic that has these 3 zeros. Now I'm going to go back and do 12 and 14 if you want to watch a couple more examples, but if you think you've got it, just go on and go from there. Okay, here's 12. Those were easy zeros to get, so x times x is x squared plus another x minus 4x minus 4, so that became x squared minus 3x minus 4. Multiplying in this one, so there's an x to the third minus 3x squared minus 4x. 3 times that, it'll be a plus 3x squared. 3 times this one will be minus 9x, and 3 times negative 4 minus 12. For a grand total of x to the third, takes care of that one. Negative 3x squared, positive 3x squared is 0. Negative 4x and negative 9x is negative 13x, and then the 12. And the last one down here, I've got a negative root 5 as the conjugate. So this is x minus 4, and x minus root 5, and an x plus root 5. I'll do these two first. X times x is x squared. Okay, there's a positive root 5x, and here's a negative root 5x, so that adds up to 0. And then negative root 5 times positive root 5 is negative 5. There's x to the third minus 5x minus 4x squared plus 20. So we have x to the third minus 4x to the second minus 5x plus 20. And there they are.